WP5 is the extent of applicable codes. This one is related to the standards and code of practice related to engineering. Now the relevant problems, we have to go beyond the coverage of the standards and the code of practice. It is only when the standards and the code of practice are not compatible for the relevant problems. That means there will be limited guidance from the standards and the code of practice. This leaves the students no choice except working for the solutions from the first principles, require vast knowledge and the ability to synthesize knowledge. This establishes the complexity of the problem. For WP5, you will need to prove or justify that the relevant standards and code of practice may not be fully applicable for the relevant problems. You don't have to totally eliminate the applications of the standards and the code of practice. The problem can be partially covered by the standards and the code of practice. However, to some extent, no guidance is provided by the relevant standards and code of practice. As long as you can prove the problem has gone beyond the coverage of the standards and code of practice, WP5 should be available. Next is about WP6. This is related to the extent of the stakeholders' involvement and conflicting requirements. We have conflicting requirements in WP2. This one focuses more on the issues. It is not people or stakeholders oriented. As for WP6, it involves the stakeholders, and most likely the stakeholders can be from different groups. Having the stakeholders from different groups, the interests of the stakeholders become more diversified. Now the greatest challenge here, it will be finding a balance in meeting the needs of all the stakeholders. There may be to some extent having the requirements which are conflicting. That means you have to decide some interests of certain stakeholders may be compromised, of course with good justifications. Now let us look at the full statement. The complex engineering problem involves collaborations across engineering discipline. It is still within the engineering community, but it is across the discipline. What does it mean by cross-discipline? If you are dealing with civil engineering problems, this may involve the engineering of other disciplines such as electrical, mechanical, chemicals, and others. This is about across the engineering discipline. It may also deal to the other fields. That means now it can be non-engineering and or diverse groups or stakeholders with a wide varying needs. It can be due to the other groups of stakeholders where their needs vary significantly. This is why you have to strike a balance, decide the priority while working out the solutions to the problem. Now let us look at the components here. The term here and or, it means that there will be collaborations among engineering community of various disciplines or other field, or the diverse group of stakeholders. It can be either one or more than one or all of them. As long as you can prove there are collaborations beyond the engineering discipline that the students is undertaking, this shall be sufficient to acquire WP6. With that, you require at least one of the followings. Across engineering discipline, if you involve the civil, mechanical and electrical, you can specify them at the justifications here. You only need one of these three to have WP6 as the complex engineering problem. It may also involve the other fields, such as involve the business, administrations, quantity surveyor, architects, and etc. You will need to provide relevant justifications and examples. Or you may involve the other diversified groups of stakeholders, such as government body, local authorities, the clients or employer, the general public, the end user, or certain specific groups of people. And now the requirement here for any of these, when you talk about the number of discipline, we are talking about across the discipline. Let's say you are talking about the civil engineering as the program that you are studying. You will need another additional discipline, bare minimum. Let's say mechanical engineering. Same goes to the others. But when you come to the diverse group of stakeholders, theoretically, you will require at least two groups of stakeholders, bare minimum. Of course, the more the merrier. It will make the problems to be more complex. This will be very much dependent on your design. WP7, it will be the interdependence. The problem shall involve high-level problems with many components or sub-problem that may require a systems approach. Now, how do you define high-level problems? These are the problems that cannot be resolved by resolving one single element or components. It should involve many components. There will be problems and sub-problems. The term here is many. Theoretically, if we are talking about many, it should be more than two. Normally, we would not call two as many. However, in this case, since we would like to make the culture and create awareness about complex problem solving, I reduce a bit in terms of the levels. Therefore, the spreadsheet here identify by at least two. Now you will have to highlight the relevant problems and sub-problems in order to prove that the relevant problems are really high levels. Only when you have several layers of problems and the relevant problems are interrelated, making adjustment to one level will lead to consequences to another level. That will be WP7, interdependence. Now what you need to prove here, it is not outlining the components and the sub-components. This is not sufficient because the whole attribute of this is interdependence. The components rely on each other. If you cannot prove the reliance between the components, it is still not WP7. What you see, the spreadsheet developed here serves as a template that you can use to prove the existence of complex engineering problems. It is just a tool for you to prove to the accreditation bodies you are really meeting the requirements, where the problem that you delivered and the assessment that you do relate to the levels of complex engineering problems. Bear in mind that everything will have to go back to the original statements of the problem solving. You will need to know the main emphasis and the main characteristics of the relevant problem for you to determine the WPs. We are not playing around with the terminology here. What I have shared with you is the concept. How do you interpret the content of those complex engineering problems? Next, let us talk about the applications of these complex engineering problems. Let's say in the course, knowing that they are addressing the relevant graduate attributes that has the complex engineering problems, you know that you need to have WP1 plus another 2 of the other WPs. Do you have to have all of these WP in one engineering problems? The answer is not necessary. The more attributes that you have here, the problems become more complicated. We have to go back to the fundamentals of educations. You can set the problems at very high levels of complexity, very challenging to resolve. Now, is it necessary? Is it really helping to your teaching and learning activities? You have to ask yourself, what is the purpose of education? Your motivations is not to design a super hard, super complex engineering problem that no students can resolve, proving that you are very knowledgeable. Your ultimate goal should be helping or guiding the students so that they have the ability to resolve complex engineering problems. Super hard engineering problem may affect the interest of the students in participating through the teaching and learning activities. This brings to my next point. As a part of the teaching and learning activities, you provide engineering problems to the sufficient levels of complexity as defined by the IEA. You can always go for the minimum requirements, which is WP1 plus another 2. Or if you would like, make it slightly more challenging, add a few other WP. This helps the students to build up their ability to analyze the problem as well as work out the solutions for the problems. Now, when it comes to the assessment, if it is formative assessment, you can have the complex engineering problems to the appropriate levels of complexity. Now, if you want to have summative assessment, and your intention now is to test their ability to really resolve high levels of complexities, probably you can go for more components. Everything goes back to your purpose and your strategy in delivering the course or the program. The flexibility is given to you. You may adjust the combinations. Now the next question. Where you can apply these complex engineering problems? While conducting the teaching and learning activities, you can discuss them during the lecture. You can have them in the tutorials. You can incorporate them in the assignment or presentations or other student-centered learning, and etc. When it comes to the assessment, you may have those in any of these assessment strategy. It can be in the progress test, can also be in the assignment reports or presentation evaluations, other types of reports, other types of evaluation methods, and even final examinations. As long as you can prove it, those problems are really complex engineering problems. There is no restriction that complex engineering problem can only appear in the assignment and the assignment report. Although this probably is the simplest way to do it. Some university even try to have those in the final exam, which is okay also. Now the next question. How many complex engineering problems shall be required in the course? 1, 2, or 3, or as many as you can produce. Based on the templates that produced here, one complex engineering problem we have to fill in one form. If you have so many complex engineering problems, this shall end up to be a lot of paperwork. Now coming back to the question, how many complex engineering problems you should have within a course? Based on my personal understanding, first we will need to look at the COs of the course. Check the mapping of those COs. If the COs is attending to the POs that are in line with WA1 to WA6, then you will require complex engineering problem. Each CO should have at least one. Let's say now CO1 is attending to PO1, CO2 attending to PO2, and CO3 is attending to PO9. Then you will have two CO really relevant to the complex engineering problem. The third one do not have the complex engineering problem. In this case, you will need one complex engineering problem plus another one, which is meant for CO1 and CO2. As for the CO3, you don't have to have complex engineering problem. You can have more, which theoretically you should have more, but from the practical perspective, it may be quite difficult to manage. As a start, we will just need to prove the existence of the complex engineering problems if it is required. Taking another scenario, if your CO1 attending to PO1, CO2 attending to PO2, and CO3 attending to PO3, that means all the CO will have their own complex engineering problem. You will require minimum one each. Then you will have to create at least 3 complex engineering problems. You will have 3 field form of this. Again, this is for the start. Remember, we talk about outcome-based educations. There will be continuous quality improvements. Once you have already established the complex engineering problem, meeting the minimum requirements, when the complex engineering problems should be available, your next step here, it will be you improve progressively over the semesters. Let's say now you have all 3 COs attending to PO1 to PO3. For the first semester you offer the course, you will require 3 complex engineering problems. The second semester onward, you will keep the first 3 complex engineering problems, add up accordingly more complex engineering problems. Make sure it provides a good coverage towards the course outcomes. This leads to the next question. How many complex engineering problems should be sufficient? I would say that the complex engineering problems will be considered sufficient when you have covered all the scopes of the course outcome that require the WP. Normally, a typical course outcome will clearly specify the behavior as well as the conditions. The conditions normally define the scopes. it will be until all the scopes under the respective course outcome that require complex engineering problem. Each scope should have at least one complex engineering problems. That will be sufficient. Let me restate this. How many complex engineering problems should be required in one course? It is depending on the numbers of CO attending to the graduate attributes that require the complex engineering problems. Each course outcome attending to any of WA1 to WA6 shall have one complex engineering problem. For the first semester you offer the course, you make sure one each for the respective COs. The following semester you show improvement. You adding more until to a state that all the elements within the course outcome have covered with the relevant complex engineering problems. Then you come to a state of full-fledged complex engineering problem covering all the necessary parts of the course. That will be the simple rules that I would recommend you to do.